so we've been talking about parallelograms, and parallelograms cover four-sided figures where the opposite sides are parallel. But then we get into specific parallelograms, and we've got rectangles and squares and rhombus and a bunch of other ones that we're going to go over every day. And basically the way this works is that each one has all the properties of a parallelogram plus a couple more that makes it specific to what we're talking about that day, okay? So if we have a rectangle typically looks like this, okay? Let's do a better one. So if we look at the rules yesterday for the properties of a parallelogram, I'm going to make some tick marks on here. Opposite sides are parallel. Do you remember those tick marks? So opposite sides are parallel. Opposite angles are congruent. Got it? We're going to leave that for a while. Opposite angles are congruent. Got it? Opposite sides are congruent. We can mark that. So this is 1 and 1 and 2 and 2. So opposite sides are congruent. Yeah. Consecutive angles are supplementary. That's still the case. So this guy and this guy add up to 180. Consecutive angles are supplementary. That's still true. So these add up to 180. Got it? And the diagonals bisect each other. That's a parallelogram. So the diagonals bisect each other. And this is stuff we talked about yesterday. So that and that, they bisect each other. But I'm going to leave the markings off because there's something about a rectangle that's different. Okay? So now we're going to add the things. This is all a parallelogram. Now we're going to add things that are just pertain to the rectangle. Let me change this to blue. And there's two things we're going to add. All four angles measure 90 degrees. And the diagonals are congruent. That means that all of these are 90 degrees and all of these pieces are equal. They bisect each other and they're the same length. That means all those four pieces are congruent. So we know that those two angles are vertical angles from chapter 3. We also know that vertical angles are congruent, so we can set those two equal to each other, okay? So I'm going to take the 10x and move it over this way, and we get 2x equals 20. So x equals 10. Are they asking me for x in number 5?
Yes.
No, they're not. Look at number 5 again.
Why can't you just do 22x?
So if they want the measurement of angle AED, we know it's 12x, and we know x is 10, so it's 12 times 10, which is 120. That's the answer they want. They don't want the 10. They give us the two pieces of that diagonal, right?
Yeah.
Now go to the picture. Excuse me. Go to the picture where I marked up the triangle. What do we know about those two pieces? They're equal to each other because they bisect each other. So what equation do I put on this one?
36 equals 2x.
Yep, and I like the x on the left. Makes it easier. So we have 2x equals 40 and x equals 20. What are they asking for on number 1? They're asking for what on number 1? What does it say they're asking for?
20.
X. Did we do it? You don't have to plug it in that time. If I know that these diagonals are equal, what do I know about those, the left and the right triangle? That left triangle that's facing in and that right triangle. What kind of triangles are they if they have two sides that are equal? It starts with an I. Isosceles, right? So if those two sides are equal, this angle is equal to this angle, and this angle is equal to that angle, and they're all equal to each other. Got it? Are you writing that down? And we already know that these angles are equal to each other because they're vertical, correct? We can also say that these angles are equal to each other. So the yellows are equal to each other, the blues are equal to each other, the reds are equal to each other, the opposite reds are equal to each other. Got it? The angles of a triangle add up to 180, so between all that information, you can figure out number 9.